6 minutes. That's all the time astronomers had to coordinate a global emergency response when Atlas appeared in our telescopes, behaving like nothing we'd ever seen before. Picture this: ground control rooms erupting into organized chaos, ESA servers calculating trajectories at breakneck speed, and the most expensive space telescope ever built pivoting away from years of scheduled observations to focus on a single, terrifying anomaly. What they discovered in those crucial minutes of observation has left the scientific community scrambling for explanation, and what we're about to reveal will show you exactly why this discovery is being called worse than anyone expected. On August 6, 2025, the James Webb Space Telescope entered a rare and critical emergency override to capture data on 3I Atlas, an interstellar object unlike anything astronomers had observed before. Normally, JWST operates on a strict schedule, with every observation carefully planned weeks or even months in advance, balancing the delicate choreography of orbital mechanics, fuel consumption, and instrument availability. Pausing this finely tuned program is not done lightly, as even a small miscalculation can cost days or weeks of science, or risk damaging sensitive subsystems. The urgency arose from ground-based observations showing that 3I Atlas was accelerating and displaying unexpected spectral signatures. Within minutes, the mission operations team had to decide whether to override the main science program. Approval for such an override required unanimous agreement from the highest levels of the project, including the project scientist, because the risks were high and the opportunity fleeting. The telescope pivoted, instruments activated, and the entire operations center was on high alert, monitoring every telemetry signal as the team raced to ensure nothing went wrong. This emergency intervention was historic because JWST had only performed a handful of overrides since its launch, and none had ever targeted an interstellar object. Every other observation, from distant galaxies to exoplanet atmospheres, was temporarily suspended. The situation underscored the extraordinary nature of 3I Atlas, which was behaving in ways that broke the normal rules for comets, prompting astronomers to mobilize their resources instantly to capture a fleeting window of unprecedented data. The override not only demonstrated the telescope's flexibility but also highlighted the stakes involved in studying interstellar visitors. Unlike typical comets, whose paths and chemical compositions are relatively predictable, 3I Atlas demanded immediate, full-scale attention. Its arrival was a rare cosmic event, and missing it could mean losing the chance to understand a body formed in conditions potentially very different from anything in our solar system. The tension in the control room was palpable as scientists worked against the clock, knowing that any delay or error could compromise the mission, but also that the data they were about to capture could reshape everything we know about interstellar objects. This moment marked the beginning of a high-stakes observation campaign that would uncover chemical, physical, and dynamic properties of 3I Atlas that had never before been recorded, setting the stage for a story of cosmic anomalies, scientific debate, and mysteries that reach back into the very history of human observation of the heavens. Astronomers had anticipated that 3I Atlas would behave like a typical icy comet, slowly releasing water vapor and forming a faint, predictable tail as it approached the sun. Instead, the first data packets from JWST painted a picture that defied every expectation. The comet's coma was saturated with carbon dioxide at levels never recorded before, and the instruments detected metallic nickel in abundance while iron, normally found alongside nickel in comets and meteorites, was almost completely absent. This chemical imbalance was so extreme that seasoned experts in interstellar bodies described the numbers as alarming, even terrifying. The comet was already active far from the Sun, at a distance beyond Jupiter where sunlight is weak and most comets remain dormant. Instead of the usual sublimation of water ice that drives comet activity, 3I Atlas was venting sheets of carbon dioxide gas, a process that normally requires much more heat. The tail, thin and ghostly due to the scarcity of dust, extended for hundreds of thousands of kilometers, growing far faster than standard models would predict. Observations from other telescopes, including Gemini South and Hubble, confirmed these unexpected phenomena, ruling out calibration errors or instrumental glitches. Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. Every team cross-checked the data against known comet behaviors and previous interstellar visitors. Even Borisov, the last interstellar object to pass through the solar system, did not approach these levels of carbon dioxide dominance or the extreme nickel-to-iron ratio. The production rates calculated from the spectra showed carbon dioxide pouring out at 8 times the rate of water, a ratio completely off the charts. Dust, normally a major contributor to the brightness and structure of a comet's tail, was nearly absent, making the comet appear almost ethereal, as though it were glowing from the gas itself. Scientists immediately realized that this object was not just unusual, it was a chemical enigma. The composition suggested a parent body formed under conditions vastly different from those in our solar system, perhaps in an environment where water was scarce and carbon dioxide ices dominated. Alternatively, it might reflect an unknown chemical or physical process that had never been observed. Whatever the explanation, 3I Atlas was rewriting the rulebook for how comets form and behave, challenging decades of expectations and sparking intense excitement and concern among astronomers around the world. The implications of these initial observations went beyond mere curiosity. The chemical signatures hinted at a history and origin completely alien to the solar system, raising fundamental questions about interstellar chemistry and the diversity of planetary systems. Scientists were suddenly looking at a visitor whose very makeup seemed to defy the laws and patterns established by centuries of comet studies, signaling that the story of 3I Atlas was only beginning to unfold. Ground-based telescopes immediately began sending real-time observations of 3I Atlas as soon as its unusual behavior was noticed. Every new measurement mattered, as the comet was accelerating unpredictably and its trajectory was shifting by the hour. Teams across multiple observatories scrambled to track its path, gathering positional data that could determine exactly where JWS 6 minutes. That's all the time astronomers had to coordinate a global emergency response when Atlas appeared in our telescopes, behaving like nothing we'd ever seen before. Picture this: ground control rooms erupting into organized chaos, ESA servers calculating trajectories at breakneck speed, and the most expensive space telescope ever built pivoting away from years of scheduled observations to focus on a single, terrifying anomaly. What they discovered in those crucial minutes of observation has left the scientific community scrambling for explanation, and what we're about to reveal will show you exactly why this discovery is being called worse than anyone expected. On August 6, 2025, the James Webb Space Telescope entered a rare and critical emergency override to capture data on 3I Atlas, an interstellar object unlike anything astronomers had observed before. Normally, JWST operates on a strict schedule,